Yes, hi everyone. So welcome back to Power Electronic Control of Drives online series. So in previous class, we solved some problems regarding to single phase fully controlled converter or semi converter fed separately excited DC motor as well as shunt motor. And today, let us we solve the problems on series motor drive. That is when it is excited, when it is connected, when it is fed with the single phase fully controlled converter, or when it is fed with the single phase half converter. Okay. Yes. First, you take the problem. Yeah. Here 230 volts. Here 230 volts. Here 230 volts, 750 rpm, 750 rpm, 25 amps, 25 amps, DC series motor, DC series motor, series motor is is driving at driving at driving at rated conditions, rated conditions, a load, a load whose torque is whose torque is proportional to whose torque is proportional to speed squared, speed squared, speed squared. The combined resistance of the combined resistance of armature and field, armature and field is 1 ohms, is 1 ohms. Then calculate motor terminal voltage, calculate motor terminal voltage yes, motor terminal voltage and current and current for a speed of for a speed of 400 rpm, 400 rpm. State assumption, state assumption to solve this problem. to solve this problem. Okay, yeah, this is the problem he has given. Yes, if you observe this problem, it is the rated conditions of the DC series motor is given. What are the rated conditions? V1 or V is given, and it is 750 rpm. N is given, and armature current or series field current or line current, so those are given, IA1 and rated condition. So he states that the torque is proportional to N square, but we know that for DC series motor, torque is equal to Ka pi into Ia, or you can also write this as Ka Kf into Ia square, as we know, and we can neglect the term, that is Kres into Ia. So hence we can write this equation as Kaf into Ia square. But he states that, so here the load, so which have the torque equation that is directly proportional to square of the speed, and the combined resistance, that is armature and series field resistance, is 1 ohm. Then we need to you need to calculate the motor terminal voltage and current at a speed of 400 rpm. Yeah, the speed 400 rpm. At the 400 rpm, what is the terminal voltage and what is the rated speed? And here you need to give the statement of assumption to solve this problem. Okay, yes, first. Yes, so first let us write the rated conditions. That means here I am taking the rated conditions as subscription 1 like this. That is V1 is equal to 230 volts. N1 is equal to 750 rpm. This is the given data. And IA1 is equal to 25 amperes. Okay, and we know that the rated torque tau 1 is equal to Ka pi into Ia1, or you can also write Kaf into Ia1 square. Okay, this shows that the torque is proportional to square of current, but it is given that the torque is proportional to square of speed. Hence, armature current is directly proportional to speed. That means he has given it is directly proportional to n square. Yes, therefore we can write IA1 is proportional to, or IA is proportional to n like that. Yes, this is based on the problem, and we cannot shoot that for all problems the same relation will carry. Okay. Yes, Ia is directly proportional to n, and it is given that the torque is proportional to speed square, and hence we can write torque 1 is proportional to Kaf into omega 1 square, or you can also write Kf into omega 1 square, or you can also write Kaf1 into n square, because n is different, omega is different. N is in rpm and omega is in revolutions per radians per second. Sorry, radians per second. Okay. Yes. Now, as we know, Ia is proportional to n, I can write Ia1 by Ia2 is equal to N1 by N2. N1 by N2. Now, what about the armature current at 400 rpm? Yes, so that is, you can write Ia2 is equal to Ia1 into N2 by N1. Therefore, this value is Ia2 is equal to, yes, Ia2 in the sense the armature current at 400 rpm. Ia1 in the sense 25 into 400 by 750. This will be approximately 13.33 amperes. 13.33 amperes. Okay. Next, what about EB1, back EMF1? Yes, back EMF, that is EB1 is equal to, for series motor we can write KAF into Ia1 into omega 1. KF into Ia1 into omega 1. Okay, and we know that, as we know that EB is equal to V minus Ia into RA plus RSE. That is, EB is equal to V minus Ia into RA plus RSE. Now let me try to find the back EMF at rated conditions. That is, EB1 is equal to, rated terminal voltage is 230 volts minus Ia, that is 25 into 1. This will be 205 volts. Yes, this is at the speed of 750 rpm. That is rated speed. 750 rpm. Then what is back EMF at 400 rpm? Yes, we know that EB is directly proportional to N into Ia. So hence we can write this as EB1 by EB2 is equal to N1 Ia1 by N2 Ia2. N2 Ia2. So from this, what is EB2? Yes, EB2 is equal to, EB2 is equal to EB1 into N2 Ia2 by N1 Ia1. Now we know all values. EB1 we know, N1, N2, Ia1, Ia2 values we know. So let us substitute these values in this equation, and we found the value of EB2. Okay, therefore EB2 is equal to EB1 205 to N2 400, Ia2 13.33 over N1 750, Ia1 25. So hence, how much this value? It is 58.31 volts. 58.31 volts. Then what is terminal voltage at this point? Yeah, what is terminal voltage at this point? As V is equal to, or I can say V2 is equal to EB2 plus IA2 into RA plus RSE. So which is given by 58.31 plus 13.33 into 1. So hence this will be 71.64 volts. Yeah, this is the solution. Now, what is the assumption we made to solve this problem? Here, the flux is directly proportional to armature current or the field current, that is series field current or armature current. That is the assumption. Okay. Yes. Next, write in the same problem. Write in another problem. This same motor, let us we take. Same motor will take. Yeah, same motor. Let us we take. And let us we connect this motor to the single phase half control converter. Let's write in the problem. Yes, I will dictate that. A 230 volts, 750 rpm, 25 amps, DC series motor, DC series motor is connected to single phase half control converter, control converter, converter, AC supply of AC supply of 400 volts, 400 volts. What should be the firing angle? What should be the firing angle for a speed of 750 rpm and for a speed of 400 rpm. Yes, as it said, the torque is directly proportional to square of the current, and Ra plus Rse is equal to 1 ohms as he given in the previous problem. Yes, you need to find the value of firing angle alpha. The same problem, but here It is connected to the single phase half control converter. The AC voltage, that means this is RMS voltage he has given. Now, yes, at 750 rpm. At 750 rpm. Yes, what is terminal voltage? VA is equal to 230 volts. Okay. Now we can equate this 230 volts to the our equation of single phase half control converter, that is to Vm by pi into 1 plus cos alpha is equal to 230 volts. Now Vm in the sense root 2 into Vrms by pi into 1 plus cos alpha. This will be equal to 230 volts. Okay. Now here let us substitute what is Vrms. Vrms, that is AC voltage given is 400 volts. That is root 2 into 400 by pi into 1 plus cos alpha 1 is equal to 230 volts. Then 1 plus cos alpha 1, this will be equal to 230 into pi by root 2 into 400. Just put all these values in your calculator. See how much value you will get. Yes, any one of you answer please. Yeah, this is around 1.277 approximate value. Yes, you should remember that this value must be greater than 1. Sir, that is 1 point something like. If it is greater than 2 in the sense, it must be less than 1 only, less than 2 only. If it is greater than 1 in the sense, greater than 2 in the sense, cos alpha cannot define for greater than 1 value. It is always defined for less than 1 only. So hence this value must be less than 2, should not greater than 2. Okay. Therefore cos alpha 1 is equal to 0.277. Hence alpha 1 is equal to 73.91 degrees. Okay. Now what is VA at 400 rpm? Already we calculated in previous problem, we calculated VA for 400 rpm. At 400 rpm. Yes, we calculated this value as 71.64 volts like that. Yeah, 71.64. Now let us we equate the 71.64 to the Vm by pi into 1 plus cos alpha. That is root 2 to 400 by pi 1 plus cos alpha 2 is equal to 71.64. Yes, then 1 plus cos alpha 2 is equal to 71.64 into pi by root 2 into 400. It is around 0.398. 0.398. Okay, then what is alpha 2? Alpha 2 is equal to 126.94 degrees. Yes, 126.94 degrees. Okay, yes, so now let us solve one more problem. A 220 volts DC series motor a 220 volts DC series motor a 220 volts DC series motor runs at 1000 rpm runs at 1000 rpm in clockwise and takes armature current of and takes an armature current of 100 amperes 100 amperes when driving a load when driving a load driving a load with constant torque with constant torque resistance of the armature and field winding are resistance of the armature and field winding are 0.5 ohms each 0.5 ohms each. Find the magnitude and direction of the motor speed. Find the magnitude and direction of motor speed and armature current if the motor terminal voltage is reversed. If the motor terminal voltage motor terminal voltage is reversed. And number of turns in the field winding is reduced to 80%. And number of turns in field winding is reduced to 80%. Assume linear magnetic circuit. Assume linear magnetic circuit. Magnetic circuit. Yes. Yes, let us we solve this problem. So what is given? It is DC series motor. First one is DC series motor. Rated voltage is 220 volts. Rated armature current is 100 amperes. When driving a load with constant torque, and armature resistance, series wheel resistance, both are 0.5. That means if club these two, you will get 1 ohms. If you club these two, you will get 1 ohm. So that means, yes, what you should remember. Yes, here you cannot place RA plus RAC is equal to 1. This will be RA is equal to, sorry, you cannot place RA plus RS is equal to 0.5, but here you have to place RA plus RS is equal to 0.5 plus 0.5. This will be equal to 1. This is equal to 1 like this. Okay. Okay, so let us solve this problem. So just you observe how I solve this problem. It is somewhat important. Yes, so first we know that the torque is proportional to product of flux and current. As a magnetic circuit is linear flux and it is proportional to the field current. So hence we can write torque is directly proportional to Ka pi into Ia. Okay, and here we can also write this as torque is equal to Ka Kf into Ia square. Yes, for rated condition, I will take this as tau 1. Okay. Yes, here let us we assume Ia1 is the current at speed of 1000 rpm. That is rated speed. So hence, what is tau 2? Ka pi 2 into Ia2. Yes, here pi 2 is equal to Kf into Ia2. Yes, since he said that in the problem the field turns are reduced to 80%. So where it will be affected? It is affected at flux. So therefore, I can write this as this is 0.8 Kf into Ia2. So hence I can write the equation as pi 2 is equal to 0. Sorry, tau 2 is equal to 0.8 Ka Kf Ia2 square. Okay, Ia2 square. Now he said that torque is constant. Torque is constant in the sense I can write tau 1 is equal to tau 2. That's where this equation is valid at 400 rpm. ఇంతేనా స్పీడ్ ఇచ్చింది. No, it is not 400 rpm. It is when the field winding is reduced to 80%. Okay, but tau 1 is equal to tau 2. That means you can write 0.8 Ka Kf Ia2 square is equal to Ka Kf Ia1 square. Ka Kf will get cancelled. Now what is the relation? Here I can write the equation for Ia2 as, it is Ia2 square is equal to Ia1 square by 0.8, or Ia2 is equal to Ia1 by square root of 0.8. This is 100 by root 0.8. Therefore, Ia2 is equal to 111.8 amps approximately. Yes, here when the polarity of the supply voltage is changed, then what happened? Both armature current and flux will change. As we know, torque is directly proportional to current and flux. Okay, so whenever the supply voltage polarity is changed, then the direction of armature current as well as flux also changes. Therefore, the direction of torque will not change. Yes, this will be minus, this will be minus, minus into minus, it is plus. The direction of torque will not be changed. Hence, it rotates in the same direction. Hence, the motor continues to rotate in the clockwise direction only. The motor continues to rotate in the clockwise direction only. Okay, then what is back EMF at 1000 rpm? Yes, back EMF at 1000 rpm is EB1 is equal to 220 VA minus IARA, 100 into 0.5 plus 0.5, that is RA plus RSE. This will be, sorry, it is 0.05. 0.05. This is 210 volts. Okay, 210 volts. Then what is EB2? EB2 is equal to 220 minus IA2 is 111.8 into 0.05 plus 0.8 into 0.05. Okay, it is around 209.94. The small change is there. Then what is N2? Yes, probably N2 also will be near to 1000 rpm because back EMF is very near. So like that we assume, like that we think, but it is not very near to that value. So let us see how much this value. Okay, we know that EB1 by EB2 for series motor, EB2 is equal to EB1 by EB2 is equal to N1 IA1 by N2 0.8 into IA2. Okay, so therefore what is EB2, sorry, N2 you need to find. What is the value of N2 from this equation? Hence N2 is equal to EB2. Yes, EB2 value is 209.94. EB2 into 100 into 1000 divided by divided by 210 into 0.8 into 111.8. So then how much this value? It is 111.7 RPM. Okay. Yes, this is how we can solve this problem. So this is how you need to take when he states that the field winding turns, the number of turns in the field winding are reduced or increased to 0.8% or 1.1%, 1.2% like that, then you need to take the considerations like this. Okay. Now today also I will give one problem to you as a homework for the practice session. Yes, read on that. A series motor drive yes, a series motor drive is connected to single phase semi converter. Single phase semi converter which is supplied from which is supplied from which is supplied from 230 volts 50H. This is input voltage of single phase semi converter which is supplied from 230 volts 50H. The field and armature resistances are field and armature resistances are 1 ohm and 1.5 ohms respectively. 1 ohm and 1.5 ohm respectively. The torque constant. The torque constant. Torque constant. Torque constant. MAF is 0.3 henries 0.3 henries 0.3 henries and load torque is 20 newton meters. Okay, the damping coefficient damping coefficient is 0.15 Newton meters second per radians. Second and radius. Calculate the average armature current. Average armature current. Average armature current and speed when SCRs are triggered at angle of 35 degrees. When SCRs are triggered at an angle of 35 degrees, the current is continuous. Current is continuous. Let's try to solve this problem. So here you have to go with the trial and error procedure. I try to solve. If you face any problem, and tomorrow I will discuss this problem with you. Okay. Yes, thank you for listening this class, and I hope all of you are doing good. Stay home, stay safe. Okay. Yes, thank you one and all.